Alright, we're here back in the lab, and I'm going to be straight up and honest. I've filmed this video before, but the reaction didn't actually work the first time. And I think I know why that is, hopefully. But I was feeling pretty confident beforehand. So what I went and did was I used up the entire supply of cyanamide that we've made in the previous videos. And it didn't work, so I've had to go and remake the cyanamide. I didn't film that. It basically involved a fire and a paint tin and a leaf blower. So I didn't use a bonfire for that. And it's pretty good, it passes all the tests, so we're going to use that. The annoying thing is I also used up 50 grams of the hydrazine sulfate. So that's annoying. So we don't actually have much of that left. I've got, this is as much as we got from the hydrazine sulfate video, and I've got a little bit spare from my just sort of supply I have around for things. And so it's about 15 grams in total of hydrazine sulfate. We've got about 88 grams of cyanamide. But we'll only be using about 8 or so grams, 8 or 9 grams, with the, maybe 10, with the 15 or so. I've got the ratios written down somewhere, with hydrazine sulfate. Now, a key thing about this is there's a lot of pH controls, and there's a lot of temperature control. And if you don't do the pH or temperature control correctly, the reaction stuffs up, and you end up recording 3 gigs of video with no result. So we're going to pay attention quite closely today to the pH changes and monitor them closely to make sure the reaction succeeds, and I don't chuck another temper tantrum on video and say fuck a lot. Alright, let's do this thing. We have pre-mixed. Turns out I had a lot more hydrazine sulfate than I thought. I had about 34 grams of hydrazine sulfate, and so I mix that with 24 grams of the cyanamide, and we're just going to mix them while dry without spilling it everywhere. Don't really have to be all crushed up or anything. Oh no, the cyanamide, it would be helpful if the cyanamide was crushed up, but the hydrazine sulfate should mainly dissolve. 40 mils of water here. It's at 40 degrees, which is where we want it, and we need pH of 9.5 during these gradual additions. So we're going to do the pH adjustment with the sulfuric acid. So we'll just go ahead and add a spoonful now. And if we grab our tiny bit of pH paper. I don't have a lot, so I'm tempting to conserve it somewhat. It's acidic at the moment. Now, it won't stay acidic. I feel like the only reason it's acidic is residual sulfuric acid and hydrazine sulfate, which is why it's causing a tiny amount of bubbling. You can see we're reacting with a bit of carbonates in the cyanamide. Now if you're doing this, you're probably a better chemist than I am, and you probably won't have residual acid in your hydrazine sulfate. You probably won't have carbonates in your cyanamide, so this won't happen to you. This is just a problem I have because I'm shit at what I do. Okay, I've just added the rest of the cyanamide hydrazine mix, and it was probably a poor choice. I added a bit too quickly, and we've risen to 60 degrees, so I'm terrible at the temperature controlling already. I'm assuming it's just the reaction between the excess acid and the carbonates that's making the temperature rise. So we'll let that settle down a little bit, and then we'll have to start pH adjusting, because it's going to get a little bit more basic as it goes on. We don't want to get, we've got to keep it at about pH 9.5, so if we don't continually add small amounts of acid, it'll go way basic, and that'll end in disaster. I might also add a tiny bit more water just because it's not stirring very well. You can hear it stirring, but you can see that it's not really stirring on the side. It gets a bit thick. And the product we're forming in the end is pretty insoluble, so a little bit of excess water doesn't really matter. Now my problem last time is what it was basic, it was acidic, just like this here, and I thought that was great. Or maybe it was just on the basic side, and I thought that's alright, and I leave it, I don't need to add any more acid, and I left it for the half an hour. And I feel like that's what made the reaction fail last time, because it slowly gets more basic, and so I'm going to sit here for the half an hour and monitor the pH a bit better. Yeah, that's just on the basic side of neutral. You can see it's a little bit green there. That's about where we want it to stay. So we've got to keep monitoring that. Yeah, stirring. We've still got another 20 minutes or so to go at this pH and this temperature, so we've got to keep monitoring the pH. Make sure the time stays where it is. Yep. Okay, it's raining quite steadily now, and it's got quite dark very quickly, so I've got an artificial light source over there. I probably should care a bit more about lighting in all my videos, yeah, I'm not really an artsy person. I'm not very good at making movies. The pH is about in the right area still, so that's good. We've maintained it in the right area for half an hour at our right temperature. So now what we're going to do is put it to pH of 7 for 1 hour at 80 degrees. So we'll do the neutralisation first and then see if that... okay, we'll crank up the heat a little bit. And then we'll start the neutralisation with the sulfuric acid. And then for the hour, I think I've got this alfoil cap, I'm just going to put it on there because we are dealing with hydrazine, which isn't very healthy, and I think having the air around it is bad once again for the hydrazine as well. It might not be because it's all reacting there, and it probably will react with the cyanamide before it can react with the free oxygen in the air, but you know, it doesn't take any effort to put a little lid on it, just in case. You have to tell me in the comments if this, like now, this looks better than it looks in normal daylight, because I don't know if this looks weirder or like weirder in a good way on camera when I've got the artificial light there, or worse. Like, I guess you can see more details, but it looks faker. I guess that's the thing. So I don't know if I'm going for it. No, okay, I'm just rambling now, but yeah, tell me things about lighting, because that's another thing that I've found very hard. I mean, it's not as hard as working out what the hell to say and trying to be autistic in my videos, but it's up there. Now you can sort of see there's no real visible colour change past the brown of the insolubleness, horribleness. So yeah, we're at pH of 7 as neutral. So we'll get it cranking up the heat, get it stirring, and we'll leave it be. And I'll turn off this light so I don't use my electricity budget for the year this hour. It's just done a little bit over an hour. I just checked the pH and we're at neutral still, and oh fuck the light, hold on. Yeah, better. Maybe. I don't know. Ooh, shadows. Alright, so what we're going to do now is we're going to do the wonderful filtering here to get this solution off. And as you can probably tell by the fact that it's barely stirring, it's pretty darn thick. But as I said before, it doesn't really matter how much water we use. Well, you keep it pretty low, ish. But we can add some hot water. We will add some hot water to wash the insoluble calcium sulfate, which is precipitated out, and all this other brown stuff. I don't know, white, brown. I mean, it's just the colour of the cyanamide. I mean, calcium sulfate's white, obviously, and that makes up the bulk of the insoluble product here. Obviously, it's a bit thick, as you can see by the fact that it doesn't even flow. So we're going to use quite a bit of water to filter, but we're going to see what the colour of the liquid coming off is. Hopefully it should be a sort of a reddish tinge, which is a combination of the dye from the sulfuric acid and the yellow of the salt that we're sort of forming. Well, no, okay, I'll say that better. The granadine, we're forming a granadine derivative, and it's currently in a free base form, and granadine salts and the free base forms are typically yellow. And in this case it is, well, I've never actually seen it yellow because there's always been the dye. But that's what you're looking for if you've got a clear sulfuric acid, is what I'm getting at. And don't worry, I will cut the sound from the moment I start the cleaner. So nothing came through. I assume it's just too thick at the moment, so we're just going to add some hot water from my stylish kettle. Turn on the horrendous noise making machine again in a second. Alright, that seems to be about the right colour. Where are we going? Yeah, there, alright. So I'm just going to keep doing this, try and get all of this out. Wash it a few times until everything coming through is perfectly clear. And then I'll go on to the next step. Okay, so we've filtered off all the brown sludge over there to get quite a nice sort of reddish pink solution here. Now, a lot of people ask me about the sulfuric acid that I buy, and I must admit it was quite a hard find to find sulfuric acid in Australia. I'm not sure if it's getting better with time. It seems to be easier now. Maybe I just know where to look. So this is the acid I bought first. It came from Home Hardware. You can see that it's got a density of 1.8. So it's about 92–93%, I think, from memory. It's sort of a brown colour. It's got a small amount of dye in it, but still transparent. This is the acid I'm using constantly. Currently is the word I was looking for. Constantly and currently. It's got a density of 1.835, so that's 98%. But it has the drawback that it is this. Well, I mean, this is 60% acid, so the actual acid itself is really black. It's got a lot of dye in it. I can get rid of it. I haven't been bothered yet because it involves peroxide and then reconcentrating it, and it's a bit of effort. These were both $50 per litre, which is, I guess, is expensive. It's not too bad, I guess. Obviously this one's the better buy because it's got more acid and this has just got more water in it. We're in the same price. This one came from Stratco. Did I say that? Yeah. And they don't ask you any questions when you buy it, and that's alright, even though they really should, because these are super dangerous products. This one barely even says, like, it's just sort of like, it doesn't even look that threatening. It's got a small corrosive thing on there and it says, oh, use acid resistant face shield. Oh, dissolves grease, sludge, paper, cloth and skin. Yeah, so I mean, they're very dangerous products, and a 3-year-old can walk into the store and buy it. So what we're doing, okay, back to the actual experiment. Here we have, hopefully, our free-based aminoguanidine. So what we're going to do is we're going to add some acid to make it a bit more acidic, and then put it into the aminoguanidine sulfate form, and then we're going to add sodium bicarbonate, and this is 22.7 from memory. And that will convert the aminoguanidine sulfate to aminoguanidine bicarbonate, and the bicarbonate is quite insoluble in water, and so that's why we've chosen the bicarbonate. It's not particularly special in any way, really, apart from the fact that it's insoluble in water, so it's going to make extraction very easy because it will filter, it will settle out as a white solid, and then we will filter it if all has worked well, which I hope it has. And there's an acid and acidic. Alright, so then we can go ahead and add our bicarbonate here. I guess all that talk about trying to get the precise number doesn't actually matter, because depending on how much acid I added there depends on how much bicarb I need to add. But you can just add it in excess, because this is reasonably soluble and the product we're forming is quite insoluble. Don't have a... Remember when I said I was bad at chemistry? I meant it. If that overboiled, oh, I would have been so mad. Oh, I lost my shit on camera. Again, for the second time with this reaction. Except I got to upload this video, unlike the other one, which is staying deleted. Also, while you're adding bicarb, it's a good idea to check your oven to see if the dinner you're cooking has finished cooking and is starting to burn. It's genuinely surprising how shit I am at cooking. People say, oh, you know, you can do chemistry. Why can't you do cooking? But then again, I guess I am like shit at chemistry. Like, I try a lot. Like, I'll give myself points for trying, but like, I genuinely stuff up most things I try. So maybe that's the thing with cooking, I just don't have the enthusiasm to try. So like, I don't actually succeed. That was very philosophical of me. So we've added all the bicarb and the bubbling has appeared to calm down. So we're waiting for it to precipitate, and usually there's quite a significant delay between when I think it's going to start precipitating out, which is basically straight after I add the bicarb, and when it does. And that has always caused me to panic. But just don't discard your solution, just leave it for a little while, even if it's overnight. And it will start clinging to the walls a little, and then you'll start getting a layer on the bottom and more. You don't need to cool it. If you cool it, you risk getting crystals of sodium sulfate out. I've done that before as well. That's no fun, because you think you've got like a really good product, and then you end up with a 240% yield, and you start to question the direction your life has taken. Okay, we're here a day later, and excitingly we have some product. Quite a lot of product, actually. So that's super exciting. I did check on it throughout the night, because I live a sad existence, and it did slowly build up over the 24 hours. Probably took 10 hours to properly precipitate, so you could start to see things forming after probably half an hour. But yeah, so don't lose heart if you don't see it straight away. It does take a little while, but that's great. We get to filter that out, wash with a little ice cold water, and then dry it on the pump.
Then filter, wash with a little ice cold water, and dry thoroughly on the pump.
Got our product very, very gently drying in an oven here. Doors wide open. Alright, and this is our dry product here. I don't know what's with the pink around the outside. I assume it's just some sort of decomposition. It's probably even decomposition of the dye that's made all the way from the sulfuric acid. Even though I was pretty sure I washed it out, I'm not entirely sure why it's going pink. It's quite a nice colour, but it should really be the white in the middle here. But yeah, we get to weigh it and determine yield. Okay, so we've got 5.6 grams, which seems to me very low, and that's a little disappointing, but at least we got a product this time, I've got to say. I do have some left over from another run I did of this, So we'll be able to combine these two together for the next step. Now, why do we get such a low yield? I guess it's just to do with the pH changes, and I do my best to try and get them right, but I guess a lot of it, when you're using pH paper and a lot of guessing, I guess a lot of it comes down to luck with the yields. But I do have quite a bit of cyanamide left. I've got no hydrazine left at the moment, but I'm going to just whip up a batch of hydrazine, 70 or so grams of hydrazine, and use up the rest of this, and hopefully try and get this a bit more better. A good test for purity is heating it strongly, and if it's all aminoguanidine bicarbonate, it will leave no residue. It will just all sort of smoke off, evaporate off. Whereas if there's things like sodium sulfate, sodium bicarbonate in there, they will stay behind as quite high melting point substances, so should be able to see quite clearly. So we've got our blowtorch flame here, just going to heat it. Alright, so I kind of butchered that test a little, but you can see it did clearly melt under the flame and then disappear, and it hasn't really left a trace there. That's all just molten semi-melted aluminium. So it's good. I'm very pleased with that. I could probably have done that test a lot better, but that confirms it to me. I'm happy, and we can continue on to the next step. Next video.